Born Haber cycle. Born Haber cycle consists of 6 enthalpies. They are enthalpy of formation, enthalpy of atomization, ionization energy, E for electron affinity, and lattice energy. Before we start construct Born Haber cycle, we have to know how to write thermochemical equation that involve in Born Haber cycle. So we start with FAAIEL, FAL. So enthalpy of formation. Enthalpy of formation means that heat change when 1 mole of a compound is formed from its element. So means that we want to form compound NaCl solid come from its element. So its element is Na solid plus Cl2 gas. Because of 1 mole of Cl, so we write half Cl2. Next, A. A for enthalpy of atomization. Enthalpy of atomization means that we want to form 1 mole of gaseous atom from its element. So we want to form Na gas, 1 mole of gaseous atom from its element. Element of Na is Na solid. Or sometimes we also call as enthalpy of sublimation because of change from solid to gas. Enthalpy of atomization of Cl means that we want to form 1 mole of Cl gas from its element. Element for chlorine is Cl2 gas at standard condition. So because of 1 mole of Cl, so we write half Cl2. Next, ionization energy of Na. Ionization energy of Na means that gaseous atom, so Na gas, remove 1 mole of electron. So 1 mole of electron is removed. So it will form Na plus gas. Next is E. E for electron affinity. Electron affinity of Cl means that Cl gas, gaseous atom, accept 1 mole of electron. So it will form Cl minus gas. And last is lattice energy. Lattice energy means that heat release when 1 mole of solid ionic compound is formed. So we want to form solid ionic compound. Okay, solid ionic compound is formed from its gaseous ion. So gaseous ion means that Na plus gas, gaseous ion, plus Cl minus gas. So using FAL, FAAIEL, so we want to construct Born Haber cycle. So we start with F. F is enthalpy of formation of NaCl. So NaCl solid come from its element. Element is Na, element solid, plus Cl2 gas. Because of 1 mole of Cl, so we write half Cl2. The value of enthalpy of formation, H0 formation, is equal to negative 411.3 kilojoule. Next, focus for A. A is enthalpy of atomization. So means that Na solid, and Cl2 will form gaseous atom. So Na solid, atomization, Na solid to become Na gas. So enthalpy of atomization for Na equal to positive 107.8 kilojoule. And enthalpy of atomization of chlorine, because of half Cl2, half times Cl2, so we get Cl gas. So enthalpy of atomization, Ha is equal to positive 121.3 kilojoule. Okay, next is ionization energy. Okay, next is ionization energy. So Na remove electron. So it will form Na plus gas. Okay. Enthalpy of ionization energy. Okay. Ionization energy is equal to positive 495.4 kilojoule. Next is E. E for electron affinity. So Cl gas accept 1 mole of electron, so it will form Cl minus gas. Electron affinity is equal to negative 348.8 kilojoule. And last is L. L for lattice energy. Okay, lattice energy, when 1 mole of solid compound, okay, we want to form an NaCl solid, come from gaseous ion. So Na plus gas plus Cl minus gas is equal to NaCl solid, and this is lattice energy. So how to calculate lattice energy? So to calculate lattice energy, enthalpy of formation is equal to total up all enthalpies below. So means that negative 411.3, okay, is equal to total up all the enthalpies below. So equal to 107.8 plus 495.4 plus 121.3 plus negative 348.8 plus lattice energy. So we can calculate lattice energy. So the answer is negative 787 kilojoule per mole. The difference between enthalpy of atomization and Born dissociation energy. Enthalpy of atomization means that heat absorbed when 1 mole of gaseous atom is formed from its element. So means that 1 mole of gaseous atom, we want to form 1 mole of gaseous atom from its element. But Born dissociation energy is heat absorbed to break the covalent bonds. Means that fluorine, heat absorbed to break the covalent bond. So 1 mole of F2 to break the covalent bond to form gaseous atom. So 1 mole is referred to F2 gas. So we continue to construct Born Haber cycle for CaF2. Okay, start with F. Enthalpy of formation of CaF2. So we start with enthalpy of formation of CaF2 solid. Come from its element. Its element is Ca solid plus F2 gas. So enthalpy of formation is equal to, enthalpy of formation of CaF2 is equal to negative 1220 kilojoule. Because of balance the equation, because of F2, so F2, Ca 1 mole, 1 mole, okay, balance. Next is FAA, IEL, so we focus to A. Okay, atomization for Ca solid. Atomization means that we want to form Ca gas. Okay, so the value of enthalpy of formation of Ca is equal to Ha is equal to positive 178 kilojoule. And next, Born dissociation energy of F2. Born dissociation, we refer to 1 mole of F2. So 1 mole of F2. So Born dissociation means that F2 to form 2F gas. So the value of Born dissociation energy equal to positive 318. Okay, positive 318 kilojoule. Next is I for ionization energy. Because of Ca can form Ca plus and Ca2 plus, so we follow step by step. We start with first ionization energy of Ca. So first ionization energy of Ca, so means that Ca gases atom, remove 1 mole of electron, so it will form Ca plus gas. So first, IE first is equal to positive 590 kilojoule. And then we continue with second ionization energy. So Ca plus, remove another 1 electron, so it will form Ca2 plus gas. So IE2 is equal to positive 1150 kilojoule. Next, we go to electron affinity of fluorine. Fluorine can remove only 1 electron. So 2F, remove 1 mole of electron, so it will become F minus gas. Because of 2 mole of fluorine atom, so it will become 2F minus gas. Okay, electron affinity means that we want to form F minus gas. Because of we want to form 2F minus, so we have to times 2 to the electron affinity. Electron affinity 2 times negative 328. Negative 328 refer to formation of 1 mole of F minus gas. Because of we want to form 2F minus, so we need to times 2. Okay, so next is last is lattice energy. So Ca2 plus gas plus 2F minus gas, it will form CAF. So this is a lattice energy. So how to calculate lattice energy? So remember, enthalpy of formation is equal to total up all the enthalpies below. So the answer is negative 1220 is equal to total up positive 178 plus 590 plus 1150 plus 318 plus 2 times negative 328 plus lattice energy. So we can calculate lattice energy is equal to negative 2800 kilojoule per mole. That's all for today. Thank you.